My name's Blair Layton, and I look after our database services across Asia Pacific from a business development perspective. So what does that mean? That means that I listen to customer requirements, I visit customers, obviously trying to sell our solutions for the good use cases that you have, but I also listen to the feedback and pass that back to our teams and headquarters. So after I've gone through my session, if you do have some feedback on our services or something like that, please come and find me. I'll wait outside, and I'll be very happy to hear anything that you have to say. So with that, let's get on with what we're going to talk about today, which is good old databases. So if we look at the Amazon platform, on the bottom down here where we've got global infrastructure, all of our regions across the globe, then networking, connecting all of that, and inside the regions, compute, storage, and then inside database, we have 4 main services. So Amazon RDS is for relational databases, Amazon Elasticache is for in-memory caches, DynamoDB is our NoSQL offering, hugely scalable, and Amazon Redshift is our data warehouse. So we're going to go through and talk about these in more detail. But why would you want to use these managed database services? Well, think about it today. How many people here are actually DBAs? Right, quite a few people. How much time do you actually spend either doing this yourselves or working with your colleagues to provision hardware and storage for your databases? To do the installation, the upgrading, and the patching of software? Doing documentation and managing licensing. So if you're working with the commercial vendors, Oracle or SQL Server, you've got to manage all the licensing, making sure you're compliant and not getting audited. Then the backup and recovery, the data load and the unload, as well as the security. So all of those things there, are they really adding value to your business and to your customers? These are just things you have to do. Doesn't matter what business, whether you're a bank, an insurance company, or a manufacturing company or an airline. Everyone has to do this stuff. So what we want to do is to say, well, let's take away some of that pain of you having to manage this whole stack from the power and air conditioning down the bottom here, racking and stacking, server maintenance, installing the operating system, doing the patches, the database software, patching that, and going all the way up to the application optimization. Now you say, okay, well if I move that to AWS, what do I get? Well, if we just do it on EC2, then we take away obviously the power, the air conditioning, network, and racking and stacking and all of that kind of stuff, up to the operating system. We give you an operating system image to start with, but you're still responsible for patching and managing that operating system. So if we go with managed database services, then what we're trying to do is actually move as much as possible completely over to what Amazon can do with a service such as RDS. Now this allows you then to focus on your application optimization. And that's really the value where you start being able to go back to your business and optimize the applications, improve the applications, work with the developers so they don't create horrible SQL statements in the first place, and get everything moving much more smoothly. So what that means is, assuming you and your competitor had the same budget, the same amount of resources, but one person was using Amazon and the other entity was using standard on-prem. With those same resources, when you're able to focus purely on the application, not have to worry about racking and stacking and doing the patching, installation of software and backup and recovery, you're going to stand out. That you're going to have a unique offering because you've got more resources focused on the customer than managing the core infrastructure. So let's go and have a look at RDS itself. RDS is for relational databases, and the ones we support are MySQL, SQL Server, Oracle, Postgres, MariaDB, and our new offering, Aurora. Now, it is managed for you, it's easy to get going, it's very scalable, and it's quite low cost in terms of what you pay for. You consume that and you just use it, and when you're finished, you can actually stop it and you don't pay for it anymore. So traditional cloud environment. So if we look at the key features, I can actually start a database, get it up and running, and give it to developers in about 6 minutes. And why is that not 5 minutes or something? Because I actually timed it, and I did a test and looked at the logs, and it was 6 minutes when I launched that. We can do a multi-AZ database. So that's where we have a master in one AZ, and a slave in another one. You can think of the availability zones as data centers, if you like. And then we keep that synchronously up to date. So if data in the master is committed, it's guaranteed to be in the standby before you get the result coming back. Now that gives you huge availability improvements than what you typically might have on-prem as well. We can scale a database up or down with about 60 to 90 seconds of downtime. So think about that. How long would it take you to actually resize your database infrastructure on-prem today? You would have to go and order the hardware, get the purchase order done, get it in, rack and stack it, then decide how you're going to migrate from your existing infrastructure to the new infrastructure, and that's going to take a significant amount of time. Weeks, right? Typically for many companies, it takes at least 4 weeks just to get the servers in. So I can do that with very minimal downtime. We can also apply patches with that same amount of downtime. So when we actually issue a patch and we say we're going to patch your instances, you have a window when you say, I want this maintenance to occur. And what we'll do is decide is if it looks like it's going to take longer than the failover time to perform that patch, we will actually fail over as part of the patching operation. So we're taking care of all of that for you. You can also add read replicas for the open source engines. So MariaDB, MySQL, Postgres, and our own Aurora, we support read replicas, which allows you to scale applications much more than what you could if you just had a master database. You can protect your backups and your database logs with 11 nines of durability. That's moving into S3, so that if something really did go wrong, you can be pretty sure that you're going to be able to recover your database in the worst possible scenario with 5 minutes worth of data loss. So we're going to take a backup that's already not done nightly in from S3 and then apply the database logs up until the last 5 minutes. So that's the absolute worst case. And that is very, very rare for something like that to happen. So the recovery process is you can actually recover at any point in time up until the log process. So let's say a user came in 20 minutes ago and they dropped 10 tables accidentally in MySQL. To recover from that, you can simply say, okay, I want RDS to recover this database on a new instance at this point in time before that happened. So all of that is taken care of by the RDS service. Also, we now have detailed metrics down to 1 second. And these are way more detailed than what we were providing before. So now we can see process lists, we can see network activity, we can see disk consumption, memory consumption, and so on. And that can be all down to 1 second level of granularity. Now, if you think of normal metrics inside AWS, traditionally it's 5 minutes or 1 minute. So this is a huge change for RDS and really hoping to help you debug your database problems. Not only that, we do so security is very important, and we can actually encrypt with a click and say, I want to encrypt this particular database, and all the storage will be encrypted. So there's a lot of things that we think about and offer from this particular service. And you're saying, oh, this sounds really good. I don't think it's real, right? Let's do a demo. So what I'm going to do is show you when I log in. All right, here we've got the console. This is for RDS, and I've just started before. You can see that's today, the log when we created an instance, an Oracle Enterprise Edition RDS instance, and it's running in what we call multi-AZ mode. You can see here, multi-AZ, yes. So this is a master and a slave. Now, imagine your boss has come in and said, okay, what I really want to do is I want to expand this business. We're going to need this application to go and support many more users. I need more powerful servers. Well, simply what you can do here is come in and look at the instance actions, modify this, and then from here you can see I've got an Oracle 12c database, and I'm running on a M3 extra large, which is 4 virtual CPUs and about 16 gigs of RAM. So I'm going to go through here, and I'm going to change that to an R3 4 extra large, which is 16 virtual CPUs and 122 gigs of RAM. So I put that. Everything else is the same, right? I don't want to change anything else. So we come down here. There's all the other things here. We've got like backup retention periods and minor version upgrades and maintenance windows, but we don't want to change any of that. Here, I can choose Apply Immediate. If I don't do that, it will happen in my maintenance window. But I want it to happen right now. So I click Continue, and here's what's going to change. It shows the list of things, and it just shows you we're changing the instance class to a new instance. Modify that. OK. Now that's going to start modifying and doing all that around in this service. You can now go somewhere and do something else. So what about if there's another project where we need to launch a database instance? So how quickly can we get something up and running? Well, here we're going to launch a MySQL database. And this is just going to be a development environment, so we don't care about having the availability. We're not going to do multi-AZ. So then we click Next. Now on here, we've got the different versions that we can use. We do actually support 5.7 now. So if you're keen on 5.7, you can try the new version. The instance class, oh, let's go for a M4 2 extra large. Multi-AZ, no, we're not going to do that, so we're just going to have a single instance. General purpose storage, there's actually options here for magnetic as well as provision IOPS, which is the high performance storage. Now I'm going to give this 500 gigs for general purpose storage, and then come down here. I need a database identifier, so let's call this MySQL SG, and then need a name, my name, and password. Make sure I get that right. And then on to Next. So now we've got security. I want this to be in a virtual private cloud because I don't want this to be publicly available. And then publicly accessible, absolutely not, even though it's inside the VPC. The security, I was going to go with the default. And here you can change your ports. You can change parameter groups, so the settings on MySQL that you want to set, you can change that. Here's the encryption. If you want to turn that on, it's simply changing that. And then here's the maintenance windows and backup retention. So we can actually do backup retention for the nightly backups for 35 days. And we also support the ability to do snapshots by the user, which will be retained until you delete them. So once we've done that, launch the database instance. And off it goes. So we go back to the instances. You can see the MySQL one is saying creating, and the Oracle one is modifying. So do remind me to come back and show you that this actually worked, because we did this in KL and I forgot to come back. All right. So all right, let's go back to these slides. But you can see from doing that, I've just gone and changed the whole size of my Oracle production environment, and I'm creating a new database, and I just did that in a couple of minutes. Everything else is happening in the background. And I can keep talking to you. I can do something else. So new database, Amazon Aurora. So this is something that we've been looking at in the market and saying, well, what are customers looking for? What's the feedback we're getting from our customers? And the thing is that they would like to have the performance and availability of the commercial engines with the simplicity and the cost effectiveness of the open source engines. So we want that delivered as a managed service, as in RDS, and make it MySQL compatible. So what are the types of things that we've done to the database to make this different? Because obviously we're creating yet another database. What's the value in what we've done? So the first thing is we've moved the logging and storage layer to its own service. So you can see here on the logging and storage in green, that is completely separate to the core database engine. And the storage is not on the instances that the database is running on. The way that the storage works is that when a change is made to the database, only that change is sent down to the storage tier, and the storage tier rebuilds the blocks. So it's very, very efficient to actually store and manage the whole environment. Not only that, that storage is now across 3 availability zones with 2 copies in each availability zone. So it's highly, highly durable and available. Now, the other thing is that we've made the whole operating environment use other Amazon services. So you can see the control plane on the right-hand side uses DynamoDB, uses simple workflow, as well as Route 53. So we're using other Amazon services to help control this particular service. And then we're also integrating the storage backup into S3. So you're getting that 11 nines of durability again by leveraging S3 for the backups. The other one which you can see, which is slightly different up there, the caching tier, so the database cache is a separate process. And this is very important. So if you have a crash in the database engine or you need to restart a database for whatever reason, typically you shut down everything and all the memory data is lost. Everything is obviously on disk, it's all committed and saved. But if you then start that database again, you get effectively a brownout because all of the data has to come from the disk and come back into memory as the application starts working. So what we've actually done is made the cache a separate process so that when you restart a database, the data is already there. So it becomes very, very effective to recover and to get up and running again when there are issues. Here's a comparison of how Aurora works with MySQL in a multi-AZ environment on RDS. So you can see the amount of I/O is dramatically reduced here. So you've got a primary instance sending all of the logs across to the secondary instance, which is then applying all of the operations, all the write operations on that, and sending that down to disk just as the primary did. In EBS, we have multiple copies of data, so that has to happen there as well. So there's a lot of I/O and activity happening in a traditional environment. If we come over here to Aurora, you're seeing the 3 availability zones with the storage service across each of those. The data is written from the primary instance down to the storage, and then it's automatically propagated across the other availability zones. What this means is if you have a read replica, that now becomes your standby, but it's something you can use, right? It's not just being there, redundantly being used, waiting for a failure event. The read replica also is operating off the same storage as the master. There's no need to send all of the logs and information across to the standby instance, or in this case, a read replica. What actually happens there is that you are now getting very low latency read replicas that are operating off the same storage. So the key features for Aurora: highly available, as I mentioned, with the 6 copies of storage across 3 AZs. No more MySQL replica lag at a scale that what you would have seen typically. So previously, 2,000 IOPS, we start to see traditionally MySQL with the lag going up, and some customers end up at peak times with lag operating in the minutes. Here we're talking in the milliseconds. So auto scaling of storage for IOPS and capacity, it basically will give you what you need when you need it in the storage in 10 gig increments, and the IOPS will be delivered in terms of the performance that you need. You don't have to specify that. It's parallel and distributed and asynchronous recovery. So we've improved the way that we recover a database. Typically with MySQL, it's a single-threaded recovery, and that means the delay can be quite long as it's applying all the logs that have happened from a multi-core machine. Then also, as I mentioned, the survivable caches, so no brownouts, and a faster, more predictable failover as a result. And it's actually cheaper at scale. So if you have a server today with a master, a slave, and read replicas, and you bring that to Aurora, you're going to find that the performance is better. You'll need smaller servers, and you don't need that slave. You can just use read replicas. And those read replicas are going to perform better as well because they're just doing reads, not having to apply the writes. So looking at the features of what we have for RDS across all the different engines, you can see the big ones that stand out in the storage. We can support up to 64 terabytes for Aurora, and at the other end on SQL Server, we're at 4 terabytes. All of the Linux-based ones, all of the other engines, are all on 6 terabytes. Looking at read replicas, we do support read replicas with Oracle Golden Gate, but we do not support that natively in the RDS environment, which we do with the other engines. So there's a couple of differences and things across the engines, but we're completely trying to get there and provide a consistent platform for all of the database engines. So watch this space, we're continually improving things. So moving on to Elasticache. Remember, this is our caching service, again, managed, and it supports Memcached and Redis. So why would you want to look at in-memory? Well, if you're doing IoT or you're looking at the environment of what's happening out there today, phones, tablets, cars, air conditioners, and even toasters, they reckon, are all becoming connected. And they've got to be able to respond very quickly. So there's a demand for real-time performance, and things like online games, as well as e-commerce and social apps are demanding faster and faster performance. So also, we're going to have applications where we get huge loads of users coming in at certain peaks, and they can't necessarily be retrieving data from disk. It has to be in memory to make it faster and scalable, because the database is often the bottleneck. So what's it good for? Really small, frequently used items are great to put into a cache. That avoids the data having to be either written or read from the database tier and reduces the hotspots that you actually have on traditional environments. So this is a very common use case where we see things like MySQL with Memcached in front of it for a web-based application. And Memcached acts as a session store or a store for very common objects which are constantly being accessed. And that can really help scale your applications quite a long way. So if we look here at what the different options are, Memcached is in memory. It is multi-threaded and multi-core. So you can really get quite a lot of scale even on large servers with a large amount of memory and throughput on the CPUs. Often you'll get to a point where the network will be the bottleneck of how much you can push through. There is no persistence. So you have to make sure that you design your applications that if it's not in the cache, that you can go back to the database and get it if you're doing a traditional database-related call. Because if the server goes down, your application still has to run. It supports string values. So basically, put your string data in, get your string data out. Very simple, very fast. And it now supports horizontal clustering, and we do support across availability zones as well. On the Redis side, it's also in memory, but it is single-threaded. So there's not really much value in going out and getting a 32 virtual CPU monster from us and putting Redis on that, because you're not going to get the scale of what you can get with Memcached, because it's single-threaded. It does support read replicas, though. So that allows you to then, off a master, take some of the read operations and allow the Redis master to deal with the writes. Also, it does support a limited form of persistence. So you can save data and allow that then to be used to launch other instances or to recover from data loss. And it has some interesting data types, as well as the capability to do pub/sub messaging. So there's a lot more advanced features on Redis than what there is on Memcached. But if you really just need a simple cache, Memcached is probably more ideal. If you need things like pub/sub, ordered sets, and other more advanced data types and features, Redis is the way to go. If we look at the next service, which is DynamoDB, this is our NoSQL database offering. It is designed for tier 1 applications. It's highly, highly available and highly durable. A lot of Amazon services are built upon DynamoDB. It's hugely durable and very, very low latency, and we'll go into that in a bit more detail. So from a scalability perspective here, you can actually have a table defined in the database, and you specify how many read and write operations you want on that table. At some point, you could simply have 5 units per second of read operations on that. If you want to then change that to 1 million reads, you can. And you can simply update that table and say, right, and instead of having 5 read operations per second, I now want to bring this up to 1 million. And we'll manage all of that complexity behind the scenes. So if those of you who are using like Cassandra or MongoDB on physical infrastructure, or even on AWS, think about the processes that you would have to go through to move from that low level of throughput to a huge amount. There's a lot of work involved, and with DynamoDB, we take care of that for you. It's also very consistent. So at any scale, even when you're doing that operation to change from 5 to 1 million, or if you've got a huge amount of traffic coming in, the latency is flat. And I've got a slide coming up on that to show that. It's highly, highly durable. 3 physical separate locations stored on SSDs. So when you commit something, it's guaranteed to be on 2 SSDs, eventually consistent on 3. Therefore, you've got a highly durable database operating at massive scale with low latency. The API is quite simple. I mean, it's a NoSQL type database, so you're going to create a table, modify a table, as well as do puts and gets. And that's fundamentally it. There's some new things we've added recently, like streams, but it's a very simple environment. It also supports both document as well as key value. So you can store JSON documents and put them inside DynamoDB today as well. There are no table size and no throughput limits. Okay, just think about that. Anyone play Fruit Ninja? Slicing the fruit? Yeah. All of that runs and is backed up by DynamoDB. Anyone ordered stuff on Amazon.com? You put things in your shopping cart. Come back 3 months later, still there. It's in Dynamo. Okay? So there's those types of applications out there that need highly durable data, very reliable, massively scalable. Here is a graph showing you, this is the latency here. You can see how flat that is over a period of time and the different volume of traffic coming in to DynamoDB at that time. So looking at popular use cases, ad tech, we see this where there's a huge demand for largely scalable databases with very low latency and consistent latency. If you're looking at IoT, being able to stream data into a highly performant database and be able to scale the demand up and down as needed. For gaming, and we've worked with Gumi here in Singapore to be able to scale their games, especially user management and session information, and making sure that's in a scalable database to deal with promotions and huge amounts of traffic coming in. And then also on the web side, storing user session information, profiles, etc., and making that really, really scalable. So moving from Dynamo onto Redshift, this is our relational data warehouse for data warehousing at huge scale. Yeah? So massively parallel, petabyte scale database. Again, managed service. We have two options. One is a hard drive magnetic option. The other one is based on SSD. So you can start, if you optimize fully, at about $1,000 per terabyte per year. So if you compare that for people who are using, Netezza, Oracle Exadata, Teradata, etc., and other appliances, with what pricing you can actually get there, with what we can offer here, you should find that that's extremely favorable. Also, you can just start at 25 cents an hour, and that's a really compelling way to get started and see if it works for you. So key features here. Petabyte scale data warehouse from 160 gigs up to 2 petabytes. We actually have a customer in Japan, NTT Docomo, who is storing 2 petabytes of data in Redshift today and doing analytics on that. You can actually read about what they're doing on our website. They have here the ability to do very fast parallel execution across the nodes of the cluster. And it's on compressed, sorted data and optimized hardware to deal with that. So we're creating an environment where it's a managed service with specific hardware to really deliver well on this. As I mentioned, you can start from a very low price, and you can scale up as you need it. So you could start with, say, a single node, and the next thing you know, you could be at 16 nodes, 32 nodes, and you can keep scaling that up as you need more capacity. It is managed, so it's easy to provision, just as like I showed you for RDS, the same type of approach. Come in, declare what you want, and off you go. So if you needed a 100 terabyte data warehouse, it's simple as going in the console, declaring what you need, and a few minutes later, you're going to get that available for you. There is a huge focus on security inside Redshift. So whether you're loading data, it can be securely loaded in encrypted. The access to Redshift, it can be done through SSL. So you're only coming into the leader node and getting access to that. The storage nodes below that, you don't even have access to those. It's all managed by the service. So the backups are also encrypted, and there's logging and auditing there as well. Really moving very fast on the features with Redshift as well. Since launch, over 100 new features and improvements being made to the service. And you can see, if you go and look at the history, some of these are major improvements in terms of features and functions. And a large ecosystem as well. So data integration providers, as well as visualization providers, so Tableau, Qlik, Informatica, Talend, etc. And there's many more do support this. Now I wanted to talk about one customer, which happens to be Amazon.com. They do a lot of weblog analytics because, as you know, we're pretty famous for doing a good recommendation engine. Now, if you look at going through the data here, we've got 1 terabyte plus workloads, petabyte, 2 terabytes a day coming in and growing at 67% year on year. The largest table alone is 400 terabytes. So this is pretty big scale. So we want to understand customer behavior and how customers are using our website. We had a legacy data warehouse that could process 1 week of data in 1 hour. Moving that to Hadoop to see what we could achieve there, we were able to query 1 month's worth of data in that same hour, which is quite a good improvement. For Redshift, we were able to query 15 months of data, 1 petabyte, in 14 minutes. That's huge improvement. We're able to load 5 billion rows in 10 minutes. We're also able to cut the pipeline down, which was on Oracle 90 hours, to 8 hours. And totally, we're using 64 clusters, 800 nodes across those clusters, 13 petabytes provisioned with 2 DBAs. Again, that shows you the power of managed services. From an operational perspective, people are now able to add value and do analytics and present things back to the business rather than having to manage the infrastructure. So that's it for the managed services. But what if you have something that doesn't fit into the requirements for RDS, Elasticacche, DynamoDB, or Redshift? Well, the good thing is you can also run databases on EC2. If it runs on Windows or Linux, pretty much you're going to be able to run that on the EC2 platform. And we have AMIs, Amazon Machine Images, for Oracle, SQL Server, MongoDB, and other providers as well. There are also white papers, so if you want to know how to run these very efficiently with best practices, there are white papers available for you to do that. So why would you do this? Well, there's no managed service for something. MongoDB, for example, we don't offer a managed service at this time. Maybe you want full control. Some things you can't do in RDS, like access the file system and those types of things, you may want to be able to do that. Or you simply exceeded the limits. Maybe you need on SQL Server more than 4 terabytes. Well, you can still do that on EC2. So how do you get there? Luckily, we just announced a new service recently, going back into the middle of March, called the Database Migration Service. And this starts your first migration in 10 minutes. It keeps your apps running during the migration, and you can replicate from on-prem to Amazon, from Amazon back to on-prem, or within AWS infrastructure as well. You can move data from the same databases or heterogeneously between the databases that we have listed up there. So that allows you to do things like take data from Oracle on-prem and move that, say, into Postgres for reporting in the cloud. Or maybe you want to take data from any database or a series of databases, consolidate that, and put it into Redshift for analytics. Maybe you just want to move systems, SQL Server to SQL Server, Oracle to Oracle, and move them one-off migrations. So we can support one-off migrations as well as constant migrations. So how does it work? We have your application there starting at a replication instance inside AWS on the right. Then you come along and you connect the databases and say this is the source and this is the target. Then you choose the tables, the schemas, or the whole database to move. And after that, we're going to bring the data across in bulk mode, doing selects on the tables you've selected. And then we move to CDC, change data capture. So any other transactions that are happening will be propagated across onto the target database as well. So this allows you to have very limited downtime and when you're moving to AWS. So you simply then, once you've caught up, move the application to point to the new system in AWS, and you're done. Now, this is very cost-effective. Looking at pricing here of about 1.8 cents on a T2, going up to 15.4 cents on a C4 large. So depending on how much data you're going to be processing, you can do this. Now, it comes with some storage. We do need some storage capacity on the instance. We don't believe you'll need more than this. And that's just for bringing the data in, processing it, and then sending it out to the target database. Data transfer inbound to AWS is free. And data across availability zones, if you're moving data from one to the other, is roughly around 1 cent per gigabyte. So that's great. That addresses data movement. But then what about if we want to do schema conversion? We also have a tool for that. So this helps you move the core schema, the database objects, the store procedures, and so forth, and bring them from Oracle, Postgres, SQL Server, and MySQL to the open source engines on the other side. Because we're trying to save you money, we're not going to allow you to go from Postgres to MySQL to Oracle or SQL Server. Okay? So, and there are already tools to help you do that out there anyway. So we've got sequences all the way down there to views at the bottom. You can read that as well as I can. And this allows you to do those conversions, and it gives you information on what's missing and what's wrong. So what I want to say here is that this is not a push button, off you go, everything's done. Yeah? So there will be differences on here, and there will be some things that do not migrate from this side over to that side. But it's going to help you do that process. Also, it does have a report. And in this report, it does the analysis so you can define the project and determine what is the amount of scope of work for the migration project. So do keep that in mind. Now, I'm just going to go quickly back to the demo, and hopefully everything has happened smoothly before we finish. Look at that, available, okay? So that change, remember I created this instance, you can see we created this, we've backed up the database, we've finished it backing it up. So that was from 10 to 6, I said 6 minutes, look at that, 6 minutes exactly. And here with the Oracle database, you can see that we've made the failover start here, it's gone through all the different processes and finished that. Now look here at this point, so here's the modification, 2:04 p.m., and then we finished that whole process at 2:22. But remember, the downtime is only the failover time, so 60 to 90 seconds to do that whole change. Thank you very much.